A ball is thrown horizontally from the top of a 60-meter building and lands 100 meters from the base of the building. Ignore air resistance. So remember, this ball has been thrown horizontally from the top of a 60 meters building. So that's the height. Horizontally meaning that you thrown it like this. So when you throw a ball like this, of course there'll be a point where it will now start dropping. But initially it was thrown horizontally. How long is the ball in the air? So we want to find the time of full flight. That's part one. So we can say height is equal to ut plus half gt squared. Now the height here, again, that is a 60, right? That's the height. Now initially the initial velocity in the y is 0 because this ball was thrown horizontally, so this is going to be 0. Again, at this point I can say this, can put h to be negative, but for this kind of projectile it's not even necessary me using a negative. And then plus half g is 9.8. I'm also using a positive because it didn't go up. T squared. Half times 9.8, that will be 4.9. T squared, that will be equal to a 60. Divide both sides by 4.9, so t squared is equal to, is going to be equal to, okay, let me just punch that, 60 over 4.9, 12.24, and then we want to square root this value. So therefore t is going to give us a 3.499. Part 2 of the question, what must have been the initial horizontal component of the velocity? Now the horizontal component of the velocity, right, the initial, because we have not been told at what velocity we had to throw this ball. Actually, the velocity at which we threw the ball is the horizontal component because we threw this ball horizontally. So simply say, we'll look at the range that we covered. What was the range that we covered? We've been told that the ball lands 100 meters from the base. Range is given by velocity in the x times time. Velocity, the range is 100. Velocity in the x is what we want. The time of flight is 3.499. So to remain with vx, divide 100 by 3.499, and that is going to give us 28.577. And I've just said that the velocity index is going to be the velocity because there was no y component. Therefore, we know that v is given by vx squared plus vy squared. So this will be 28.377 squared. And then you square root that. So the square and the square root will just cancel out. Part 3 of the question is saying, what is the vertical component of the velocity just before the ball hits the ground? So just the ball hits the ground, we can say v is equal to u plus gt. Final velocity. The initial velocity in the y was 0. G is 9.8. The time of flight is a 3.499. Therefore, v is going to be 34.2928 meters per second. This is in the y. Part 4 of the question is saying, what is the velocity of the ball just before it hits the ground? So now this is the total velocity or the resultant velocity. You know that is given by vx squared plus vy squared. So simply vx is 28.377 squared, vy 34.2928 also squared. Then we square root that. That is going to give us 44.39 meters per second.